Guys, welcome to my channel. This is Rajesh Yadav, and in today's video I am going to cover SAS practical question and answers. Let's move on to the next slide. This is about me and my experience and my certification. Let's move on to the next slide. So guys, if you want to learn SAS, you can contact me or you can WhatsApp me. Let's move on to the next slide. So guys, if you are preparing for SAS interview, you can take a SAS interview session. If you want SAS interview question and answers, you can ask for SAS interview PDF. And if you need any SAS software related help, you can email me or you can WhatsApp me. Let's move on to the next slide. Here is the question that we need to solve. Question is AK invested 100,000, that means 1 lakh rupees, when he was 25-year old, and RK invested 50,000 rupees when he was 20-year old. Write a program to calculate compounded return amount on 31st December 2023. Okay guys, so this is the question. Here, this is the source data set investment. What is given? So we have the name AK and JK, amount is 100,000 and 50,000. CAGR. CAGR means compounded annual growth rate, that is 15%. Next is date of birth. So date of birth for both AK and JK, 1st January 1963. And investment age. So AK made the investment at the age of 25 and JK made the investment at the age of 20. Okay guys, so what we require, we need to calculate the compounded return amount on 31st December 2023. How we are going to calculate this? So guys, if we are going to solve three things, then we'll able to solve this question. So what are three things? So these are the three things. First, we need to find out the investment date. Second, we need investment period, for how long this investment was active. And third, compounded return amount. So if we got two, then we can calculate the third. So what is investment date? So on 1st January 1963, that guy born, and when he made the investment, he made the investment at the age of 25. So that means if we add 25 to this date, then you will get the investment date. So it will be around, if you add 25 to 63, it will be around 1988, right? Roughly. So we got the investment date. Now we want investment period or duration. So from this date 1988 till this date, what is the duration? So we need a difference of these two dates. So we will get the duration. So once we got the duration, all we need to do is just to calculate the return amount. So we have all three things. We have principal amount, we have rate, and we have time. So PRT, simple interest formula, P into R into T divided by 100, we can calculate the simple interest. However, we do not want the simple interest, we want compounded interest that should be calculated annually. So annually means this 1 lakh, if we get the 15% of this 1 lakh, so return is 15,000 first year. So total amount would become 1,15,000. So next year this 1,15,000 would become the investment amount on which the 15% interest should be calculated, and that would become compounded return. So we will be solving this in SAS. Let's see how we will solve. Let's go into the SAS and solve this. So guys, I am using SAS on demand. If you don't know how to access this, you can watch my video on SAS software. I'll put the link in description. So here what I'm doing, I'm just creating the source data set. It's very simple. Just data, name of the data set, then what variable we need. We just need to create with input. We need name, that is character. So I mentioned dollar. Then amount, that's numeric. CAGR, compounded annual growth rate. Date of birth, date 9, you can see here, 1st January 1963. So we need to tell SAS that we are reading a date. So I mentioned date 9 as in format. Then investment age is 25. Run this. So I'll just do this. So this is our source data. We are able to create the source data exactly the same that is in our slide. See, okay. Now we'll need to solve the question step by step. So I am just creating a data set, data return set investment. You can double click on this one. So this data I am copying. Okay, what first question we need to solve? So we need to solve this investment date first. So I'll just mention here like this. I have given the comment. Okay, how I given the comment? Okay, let's mention this. So just press control and forward slash. So you can add the comment. So this will not execute, but it will help us to write something about what we are going to do. Okay, so I am writing when the investment happened. Let's calculate this. So how we will calculate? So this is date of birth, and if we add this investment age, we'll get the investment date. So I give invest date when the investment happened. Okay, now I want to add this 25 to this date. So guys, we cannot simply go and just add 25 to this date. To increment or decrement something in a date, we need a function called int nx. I'm sure many of you have heard this int nx. So what we want to add? We want to add a year. So interval is year. Next, in which date we need to add? So DOB, we want to add. What we want to add? We want to add investment age. Invest age. And then semicolon and run. So we are able to calculate investment date. Run. See. So here is the investment date. So you can see these are some numbers. So we know that how SAS stores date. SAS stores date as number of days from 1st January 1960. So these are number of days. So to interpret these, we need to apply a format so that we can better understand what date it has calculated. So I just simply go and format this. So you know that how to apply a format. Format, invest, date. It's up to you in whatever format you want to see these dates. So I like giving dates date 9. It's much more easy to understand. So investment date, we got it. So this guy born on 1963, he made the investment at the age of 25, and when he made the investment that day, this was the date. Okay, now we are able to calculate the first requirement. Now we need to solve the second. So control forward slash, or you can manually type also, it's not that difficult. Just give forward slash star, and then you can type requirement 2 is what? Investment period or duration. Investment duration, for how long this investment was active. So second comment I have mentioned. Now I am going to calculate the investment duration. So what we need, we got the here in the data set. If you go, we have the investment date, and when we want to calculate the compound interest, it is on 31st December 2023. So if we take a difference between these two, so 31st December 2023 and this investment date, we got our period. Okay, duration. So to calculate a difference between two dates, we use a function called intck. So I'll just mention invest, invest duration equal intck. Then we will give interval. Interval in what? We want the duration in years. Years comma, then what we need, investment date, and then another date is 31st December 2023. So we can mention date like this. If you want to assign a date or anything, we need to mention like this: 31st December 2023, and then we need to tell the SAS by giving date literal. So this is now a date. So we are calculating difference between these two dates. And then if I run this, let's go at the end and see. So we got the duration. So this guy born on 1963 at the age of 25, 1st January 1988, he made an investment of 100,000 or 1 lakh rupees. And this investment was for 35 year. So this is 35 year. And second one is this guy made investment of 50,000 on when? 1st January 1983 at the age of 20 for 40 years. Now we have everything with us. So we can solve our third requirement. So third requirement is compounded return. So there are two ways of solving this. So the first one, we are going to solve this using a long method. Okay, yearly basis. So first year we'll calculate the simple interest, then that simple interest plus the principal amount would become the first year's return. Second year we will calculate the interest on the first year's total amount, principal amount plus interest. So on year on year basis we will do. So year on year basis means we need to calculate the interest amount or compounding amount for 35 years. So every year we need to calculate that way. Means 35 times we are calculating, and this one we are calculating 40 times. So to calculate these many times we need to run a loop. Okay, because every year we want to calculate. So this question will give you a good practice of do loop also. So I'm just running. I just do a one thing. I need just assign return amount, because I need to use for every year. I'm just assigning the initial principal amount to return amount. Then I will run a loop. Do I equal 1 to, till when we need to run this loop? For this duration, because we have the duration. So the first guy, it will be for 35 years. So this loop will run for 35 years. Okay, now calculate the return amount. So I'll give a return amount. So this is our principal amount. I've already assigned this. Then the formula. What is the formula for calculating the principal amount? P into R into T, principal amount into rate into time, divide by 100. So principal amount I've assigned here, AMT. Then rate, CAGR, divide by 100. Okay, you may be asking why I haven't mentioned the time. So I am calculating this for 1 year, every year. Okay, so every year I am calculating. So each iteration. So if I give 1, okay, that doesn't really make a difference. If you multiply anything with 1, you will get the in return 1. I'll give a and I'll run. So I got the total amount. This one is the total amount, but I want it on year basis. So every time I need to print when it calculate what it has calculated. So I'll give an output statement here, and then we'll run it. Run. Okay, let's do it. All right, so this is the calculation. If you see for AK, it's repeating. And if you see the first year, I also printed the year, means value of I. So every time it gets iterated, so what the value it has calculated. So you can see the total duration is 35, and the first year it has calculated the return amount 1,15,000, because 1 lakh is the principal amount and the 15,000 is the 15% return. So it's simple. 15% of 1 lakh is 15,000. So we got the 1 lakh 15,000 for first year. Second year, this amount would become the investment amount. 15% would be calculated on this one. So that is what we call it compounding. So next year the amount would become 1,32,250, and the next year it will become this amount. And if you can see, on fifth year amount got doubled, so 2 lakhs. So in 5 years the amount we got the 100% return. Next 5 years it will become on 10th, this 2 lakh became 4, and so on. If you go at the bottom at the age of like when date of 31st December, duration of 35 years, you can see this is the amount that got returned. So what is the amount? It's like 1 crore 33 lakh 17,552 is the amount. Huge amount, right? In just the investment of 1 lakh, and a person can get this much of amount. Okay, let's talk about the other person, this JK. So this guy JK invested only 50,000, half of this person's amount, and duration was 5 years more. So we already know that amount gets doubled in 5 years. So when the AK made the investment of 1 lakh, this guy's investment already doubled. So if you go and see the at the bottom, last 40-year duration, that guy's amount is also compounded, and the amount is 1 crore 33 lakh 93,000. So if you can see here, it has 93,000, and this guy has 17,000. So even invested half of the amount, okay, this JK got the more amount. So this is the power of compounding. Okay guys, so this is not a investment class, so we just focus on our SAS solution. So we are able to calculate the compounding amount for both the guys. So this is the one way of solving this. Okay, here I saw one more thing. Here we are seeing more digits. Okay, after decimal, we can correct that also. This all we need to do is just apply a format. Format on what? This written. 8 dot. Simple. 8.2, that would work. We want 2 decimal places only. It's giving us 1. That's okay. That's because of size. Somewhere we are not. Let's remove this one. We do not want the decimal place. Right, so we are fine. So this is the amount that gets calculated. Okay, so we have solved this question using do loop. Now we'll use a simple approach. So we will be solving this question based on compounding interest formula. So I'll just delete this part. Okay, now what I want compounding interest formula. So I'll just go in Google and just find out. So this is the formula, compounding interest. Okay, so this way, CI equal, I'll just going to use this similar way. A little bit modification we will do. So just do it. Did not require this return amount because we are not running a loop now. So compounding interest or compounding amount, whatever we can give. So we have a variable already, amount, multiply by what we have here. Let's go back and see. Yeah, so 1 plus R. R is, we know that, rate. So 1, yeah, simple, plus bracket 1 plus, similar way we are going to use this 1 plus R, right? So 1 plus R means rate. This is CAGR divided by 100. Make sense? CAGR. So we got it. Next is we need to add the power. N is like interval, right? Number of times interest applies. So we'll use this. Here it's not required because the initial level we are just doing it on annually basis. So the internal one is not required. So we will do only at the outside. So power, how we use power or square something. So we use double star and then power, and for how long duration we have. So we have investment duration. You guys, I hope this should work in first go. All right, so let's run it and see if it works or not. Yeah, we got it. You can see, so here is the amount, total compounded interest, not compounded interest, let's give it a like name, compounded amount. Okay, it's not only interest. C A, compounded amount, or yeah, CA is fine. Run it. So now you can see 1 crore 33 lakhs 17,552. 1 crore 33 lakhs 93,177. So you can see this guy got the more amount. Even he has invested half of the amount of this person. I hope you understood this question and you enjoyed solving this, and it will give you a good practice. So that's it in this session, guys. If you like this practical question, please like my video, subscribe the channel, or mention in the comment section if what you like about this video, and if you like my teaching style. I'll keep creating the videos like this. We will meet in the next session. Till the time, bye and take care.